Hayaang buksan ang isipan.
Sa science o agham, tayo na sa sineskwela. Bukhasin natin ang siyensya.
Buksan ang pag-iisip.
Tayo'y likas na scientist.
Hello everyone! For today's session, we are going to discuss heat and temperature. You have learned in the previous grade that heat transfers from one body to another of different temperatures through conduction, convection, and radiation. Heat always moves from a body of higher temperature to a lower temperature. People think that heat and temperature are the same. However, in physics, although they are related, these terms are not the same. So in this video lesson, you will learn the difference between heat and temperature. Also, you will learn more about heat transfer and the factors that affect the amount of heat an object can absorb or release. What happens to the temperature of the water when heated? In the activity, the temperature of 200 ml heated and boiled water at a particular time was recorded. As time elapses, the temperature of the water increases. The temperature of the water as it begins to boil is 100 degrees Celsius and remains the same while it is boiling. In layman's term, the temperature is a measure of hotness or coldness of an object. Kinetic molecular theory tells us that all matter has molecules or atoms which are constantly moving. Thus, they have kinetic energy. Molecules are constantly moving but at different speeds and in the same direction. Moreover, the faster these molecules move, the more kinetic energy they have. The more kinetic energy, the higher is the temperature of an object. How do you determine the temperature of an object? Try this simple activity as shown on the screen. Set up 3 glasses of water. Glass A with lukewarm water or malikam-kam na tubig. Glass B with cold water. And Glass C with tap water or fresh from the faucet. Dip your left forefinger in Glass A, while the right forefinger in Glass B for 40 seconds. Then quickly dip both your forefingers in Glass C. What did you feel? This shows that our senses give us an inaccurate measure of hotness or coldness of an object, making them not reliable indicators of temperature. Thus, we need a thermometer to measure temperature. A thermometer is a sealed glass tube containing mercury and with an imprinted temperature scale. The mercury expands and contracts, causing it to move up or down when there are changes in the temperature. When a barbecue has just been removed from the fire, you know it is hot and may burn your tongue, so you do not bite it immediately. According to the caloric theory, heat consists of a fluid called caloric fluid, which flows from hotter objects to colder objects. James Prescott said that heat is another form of energy. He superseded the caloric theory by proving that a measurable amount of mechanical energy can always be transformed into definite amounts of heat. He called this quantity as a mechanical equivalent of heat and has a value of 4.186 joules, equivalent to 1 calorie. Heat is produced from molecules of matter that continuously vibrate. Heat is an energy form that transfers from a body of higher temperature to another body of lower temperature. Once heat is transferred or released, it affects the internal energy of the body. Internal energy is the total energy in a body. Thus, it includes the potential energy and the kinetic energy of molecules or atoms in an object. Joule is the international system of unit of heat. Another common unit of heat is calorie, defined as the amount of heat needed to change the temperature of 1 gram of water by 1 degree Celsius at the pressure of 1 atmospheric pressure. The three common temperature scales are Celsius, Fahrenheit, and Kelvin. Under Celsius introduced the Celsius scale in 1741, while Daniel Gabriel Fahrenheit introduced the Fahrenheit scale in 1724. Both scales used the freezing and boiling points of water as reference points. On the Celsius scale, the freezing point of water is 0 degrees Celsius, while its boiling point is 100 degrees Celsius under 1 atmospheric pressure, having 100 intervals between two reference points. On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit, while its boiling point is 212 degrees Fahrenheit, having 180 intervals between two reference points. The difference between these two reference points is divided equally into intervals called degrees. William Thomson, also known as Lord Kelvin, introduced the third temperature scale, which is called Kelvin. This scale is based on absolute zero corresponding to 0 Kelvin. It is the lowest possible temperature, and it is when the molecules of the substance have the lowest energy. Kelvin scale cannot have negative temperatures. On the Kelvin scale, the freezing point of water is 273 Kelvin, while its boiling point is 373 Kelvin. The temperature difference is 100 Kelvin. The difference in temperature between two reference points in the Celsius scale is also 100 degrees Celsius. So when comparing Kelvin and Celsius scales in terms of change or difference in temperature, 1 Kelvin is equivalent to 1 degree Celsius. The symbols degree Celsius, degree Fahrenheit, and Kelvin are used to report temperatures of objects, while Celsius degree, Fahrenheit degree, and Kelvin are used for temperature difference or change in temperature. For example, the freezing point of water in the three scales is 0 degrees Celsius, 32 degrees Fahrenheit, and 273 Kelvin, and its boiling point is 100 degrees Celsius, 212 degrees Fahrenheit, and 373 Kelvin respectively. Hence, the temperature of the water from freezing to its boiling increased by 100 Celsius degree, 180 Fahrenheit degree, and 100 Kelvin. Thus, 100 Celsius degree is equal to 180 Fahrenheit degree and also equal to 100 Kelvin. The relation between temperature in Celsius scale or Tc, temperature in Fahrenheit scale or Tf, and temperature in Kelvin or Tk are as follows. For Celsius scale, Tc is equal to 5/9 multiplied to the difference of Tf and 32, or Tc is equal to Tk minus 273.15. For Fahrenheit scale, Tf is equal to 9/5 multiplied to Tc plus 32, or Tf is equal to 9/5 multiplied to Tk minus 459.67. And for Kelvin scale, Tk is equal to Tc plus 273.15, or Tk is equal to 5/9 multiplied to the sum of Tf plus 459.67. For example, what is the normal body temperature in the Fahrenheit scale? And in the Kelvin scale, let us first convert 37 degrees Celsius to degree Fahrenheit. The formula will be Cf is equal to 9/5 multiplied to Tc plus 32. The next part of the solution is to substitute the given value of Tc, which is 37 degrees Celsius. So we will arrive with Tf is equal to 9/5 multiplied to 37 plus 32. This results to Tf is equal to 66.6 plus 32. And we will have the final answer, which is Cf is equal to 98.6, or if we round it off, it will be 99. Next is to convert 37 degrees Celsius to Kelvin. The formula will be Tk is equal to Tc plus 273.15. The next step is to substitute the given value of Tc, which is 37 degrees Celsius. So we will have Tk is equal to 37 plus 273.15. The final answer will be Tk is equal to 310.15, or if we round it off, it will be 310. When the temperature of substances changes, its molecular structure and movement also change, which results to phase change. Fusion or melting is the process that causes a solid to change to its liquid state. The amount of heat required to produce this change is called heat of fusion. When liquids release heat, the water molecules begin to move at a slower pace. The space between the molecules become compact. The process of changing liquids to solids is called solidification or freezing. When water boils, evaporation takes place. Heat is absorbed and water is converted into steam or water vapor. The amount of heat needed for a liquid to evaporate depends on the boiling point of the liquid. When water vapor releases heat, its gas state changes to the liquid state through condensation, which accounts for the formation of clouds in the water cycle. In addition, sublimation is the process of transforming a substance from solid phase directly to the gas state without passing the liquid phase and requires additional energy. On the other hand, deposition is the process of transforming a substance from gas to solid without passing the liquid phase and requires a release of energy. During any of these phase changes, energy is either given off or taken in. When a substance changes phase, the temperature doesn't change. When temperature changes, thermal expansion in solids happen, causing a change in their length, width, height, area, and volume. Molecules or atoms of materials vibrate constantly, heating these materials causing the particles to vibrate faster, fill in more spaces, and move to empty spaces, resulting in the materials to expand or increase in size. On the other hand, When the temperature is reduced, the particles vibrate slower and move closer to each other. Generally, materials expand when the temperature is increased, or contract when the temperature is reduced. This is what happens to the mercury inside the glass tube of thermometer. The mercury expands at a different rate than the tube. Thus, as the temperature increases, it rises and drops when temperature decreases. Thermal expansion also happens in liquids and gases. If 5 blocks of different metals, aluminum, iron, copper, gold, and lead of mass 100 grams, having the same cross-sectional area and same initial temperature before being placed into a block of ice, gold melts the most ice and sinks the deepest. Second is aluminum. Third is iron. Fourth is copper. And lead is the last. This shows us that although these metals have the same mass and initial temperature, they absorbed and gave off different amounts of heat. This is because these metals have different heat capacities. The heat capacity of a body is the quantity of heat necessary to raise its temperature by 1 degree Celsius. On the other hand, the specific heat is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius.